I also talk to you about this the website, Ciphering Updraft, where you can brush up your skills, your Rust skills, because there's a lot of small questions, like iterative type. It's kind of like iterative, like small problems that you do, and the difficulty just increases and increases. And I thought that was a good way of you learning Rust. Uh, but is learning Rust is one thing, right? Learning Rust or learning how to code is one thing. But there's also being able to have the logic, being able to be logical and be able to solve problems. Because you can know how to write it, you can know about code, you can have knowledge about code, uh, but you also have to be able to break down problems and then use code to solve that problem. So that's another thing that you also have to factor. So from today, we're now going to focus more on coding, and I'm gonna be giving you more problems. And I want our classes to end next week. But there's going to be a project that I'm gonna give you, and I'm gonna be behind behind your case to make sure that you finish it. So because at the end of the day, you can watch as many videos as you want, you can learn as much as you want to learn, but if you don't know how to take a problem, break it down, and then figure out how to solve that problem, it's useless. So you gotta be able to have your hands dirty. So starting from today I'm just going to go back to smart contract, what we did like last week, and to give you more, like to refresh your mind, and also give you more explanation for you to understand. And after that, I'm going to give you something to do. So tomorrow, I wanted us to have like a sort of a class work. So as we have a class, we'll all be working on our code, and we'll all be sharing our code. But unfortunately, I won't be available tomorrow. So I'm just going to give you the work, and next week when we see each other, we're going to share, and then I'm going to also share my solution with you. And then after that, I'm going to maybe have one more class, and then give you a big assignment, like a final assignment, something that can really push you to a limit. So 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 far for now, we haven't delved deep into front end, because we're focusing more on the back end. So it's the Soroban command line interface, and maybe later we get into the front end. But I really want all of you to master Soroban first before you can move into building a front end of your application. So let me share my screen, and let's get back to the introduction to smart contract. So now there's no notes, but I'm gonna try to make notes after the classes, like based on what I've shared, and then I'll maybe make a written format of what I shared. So let's go to the documentation. Come on, come on, come on, come on. These days my computer is slower than, I don't know what's going on. It's slower than usual this past week. Can you see my screen? All right, thank you. All right, so this is where you install your smart contract. I don't know if all of you have done it so far. So let me just quickly run through it. So obviously you need to have your VS Code, and And you also have to install Rust. We obviously done that so far. And then after installing Rust, you configure your you configure your editor to make sure you have Rust Analyzer and code LLDB. Let me just show you where you find it if you haven't. So you just go to extension, and then you search at extension. That's where you're going to be searching for Rust Analyzer. It's a bit slow. So you just search here and then you find it and you install. So Rust Analyzer code LLDB. You search it over there and then you install it to your editor. And also one thing that you'll see, we're now using Soroban 23 because Stellar blockchain upgraded to protocol 23. So the language is Soroban also had update. And the second that you need to have is Stellar command line interface. So this will allow you to interact with your smart contract, to interact with the blockchain using your command line. So you need to have that installed. And the next thing that you need to do is you configure your identity. So what this means is, in order for you to interact with smart contracts or even deploy your smart contracts to a blockchain, you need to have an address. So your address is your identity, your account. So you need to have an account that will enable you to do that. Like I have my wallet here. I have a wallet here. My wallet is one of my accounts. And you get this wallet by installing Frighter. You install Frighter, you have your seed phrase and all that, so on and so forth. And then you have your wallet. You can see here I'm in the testnet. Another way to create a wallet is doing this. So Stellar key generate global Alice. So global just means that you're going to be using, you'll be able to use it in a computer, not in your specific folder. So you're installing this address, this identity called Alice in a specific folder. So Alice will represent a wallet address. So the wallet address starts with G. So it's like a long string that starts with G, and then I think it's 26, length of 26, if I'm not mistaken. So when you do this, Stellar key generate global Alice network test network, you also specify this where you fund your XLN. If you don't fund, then if you don't do this, then you're just gonna create a wallet. If you don't need this part, you're gonna create a wallet that does not have any fund. So it's just gonna be an empty wallet. But here now you're specifying that in the network test, the tested network, give this specific account 10,000 XLM. So when you do this, now this address will have 10,000 XLM. So let's just do that. Because I already have Alice. Let me just do something with my name. Just choose my name. Let me clear this. Oh my goodness. Clear. And I'm gonna give it a name. So it's going to create new identity globally, and it's going to fund it 10,000 XLM. And I can even check now, I can check my address like that. I use Stellar Key's address and then the name, and then the name that I've given my address. So you do it like that. I'm gonna put my name, and then it's gonna return my address. So this is my address, and you can use, so this address will be used to deploy my smart contract, and it also allow me to interact with my smart contract. So now that you have that sorted, I introduced you to Hello World, a simple program, and then you saw there was cargo 2ML. There's a contract. The cargo 2ML as a workspace, which includes the number. So this part just tells you that we can have as many contracts under this folder, and we also specify which Soroban SDK we are using, and this is the old one, 22. So you also have to, let's check which one we're using here, because I'm expecting 23. So let's look at cargo 2ML. Not this, which one? Cargo 2ML. We're also using 22. 22. Okay, we're using we can change it to 23, but I'm just gonna leave it like that. I guess it did not install the latest one. What else? Yeah, we're not gonna get into that. Yeah, here also is important. You see the name. There's two cargo 2ML. There's for the workspace here, as you see here, for the whole folder, which is and then there's a cargo 2ML for the specific project, like this one here. And you see its name is Hello World and version 0.0. And that's all. So when I create another project, it's also going to have its own cargo 2ML, and it's also going to have the name. Now let's look at the Hello World. Let me see how much time we have. So let me not waste so much time. So I already created a project, Hello World, and so far it's not yet uploaded in the testnet. It's not yet uploaded. Let me see. Let me just cargo test it so that it compiles now, because compiling takes so long. And then we're gonna go through the code. So we have the code itself, like we mentioned before. Let me remove this because it's so like we learned before. Here, this line just says these directives tell the compiler that we're not using the standard library, and this is we are importing the Soroban SDK, and here we specify what we're going to use, which macros are we going to be using, and like here we're using contract implementation vector. We also use the environment, and we're also using string and vector. So the environment is just where it's kind of like the blockchain space itself. It's where you interact with the blockchain. Let me just show you from the documentation. There's going to be more information from here. So the environment, the env type provides access to the environment. The contract is executing within. The env provide access to information about the currently executing contract, who invoked it, contract data, function for signing, hashing, etc. Most type requires access to the environment to be constructed or converted. And here are some of the implementation that you can use in the environment. And when I say implementation is when you're using your code, you have like env dot storage, open bracket, close bracket. And here in the documentation, it tells you what it does. Like storage is for accessing or updating persistent data owned by a currently executing contract. You're gonna see it in action in the hello world. You can also use event, ledger. You can access the current ledger. You can even access the current ledger time spent, for example. So the documentation just tells you what you can do with env, how it is implemented. And so that we have. And then here's the structure of a smart contract. You have here, we have a contract, and we have contract implementation. And we also have what we call, we can also create struct. We call it contract, the directive that you're gonna be using called contract type. Let me just type it here. So this contract type is used when you are creating a struct. You know, just like when you were coding using Rust, when you're coding in Rust, there were instances where you had to create a struct. So here, when you want to create a struct in your smart contract, you have to use this directive, and then you create your struct. And don't forget to make it public so you can create a struct. Maybe the struct will be user details, for example, user details, for example. And then you have name, and then you're gonna say that the name is a string, for example. And then you have phone number is a UI, is a U32, for example. So this is up to you. So you can have, so every time when you're creating a struct, you have to have this on, you have to have this directive. So if I create another struct, I must have another contract type directive. So I'm just saying this because you need it for the exercises that I'm gonna give you. And we have contract. So they just tell us that we're dealing with smart contract, and the name of the smart contract is contract. And down here we have the implementation of contract, just like we were doing on when we were coding in Rust. We have the implementation of the contract, and we don't have a main class. We don't have a main class here because here we're dealing with the smart contract. So there's going to be accounts that are going to call these functions. For example, you want to get the owner, maybe the owner of this contract, for example, if there was an owner that you specify, and every other operations. So that's why we can't really test, we can't really run and see the outputs directly. We have to, that's why we're using the test. So the test helps us to test the smart contract itself. And we're going to see how it works. And we can also use the CLI, the Stellar CLI as well, the command line, to also do operations as well. But here, when you look at the test, you see we're using super, so using everything from here. So we're calling everything that is here. And we also use vector, environment, and string. And here we're trying to emulate a blockchain environment, because so far when you are testing, you haven't yet deployed on the test net. You haven't deployed in the test net. So you're still in your machine. So this part of the line just create an environment, a simulation of the blockchain itself. And then we create the contract ID. Because even when we deploying smart contract, the smart contract has a contract ID. So we're simulating all that. We're simulating the environment, the blockchain environment, and we also have the contract ID, and then we have the client. So the client is your wallet. The client is your wallet, and then we now here this part is now we are testing the functions that we created. In this case, when you go back here, you're going to see a hello function. So that's what we are doing this part of the code. So we're just testing that specific function, and then we putting the appropriate argument, which is a string that is called dev, and then in this part of the code, we just tell it that word, which is whatever was returned from here, anything that was returned from us using this function, must equal to this part. So it must equal to this vector. So if I use this function, it must return something, which is a vector, because according to this line of code, we're returning a vector. So this vector has to be equal to that vector. So this vector is just a vector of hello and dev. Okay, I'm gonna pause a little bit. For anybody who doesn't understand, let me know. Like, is anyone confused what I've said so far? Is anybody confused? No? Anybody confused? Not? No one? Okay, so that is what happening. So I'm gonna go back to this code in the hello world. So we just implemented a contract, a hello, and here we are in the environment because we're gonna be working from the environment. We have string, and so this hello is just gonna be taking one parameter, which is a string, and then it's going to be returning a vector. Just like we've been doing it a lot in Rust when you're learning Rust, and then it's going to simply return that. So very, very simple. And here we testing that. So when you are creating your application, because I also want you to know how to test your application. So this part doesn't change. This part doesn't really change because here, like I said, you simulating a blockchain environment. You're now taking your address, getting your contract address, and then here is your client. So this part doesn't change. Maybe the only part that's going to be changing is nothing. I think it's even better than the previous version of Soroban. So nothing changes. So this part is what you're going to be working on. So this is the only part that's going to be changing, depending on what you are trying to test. And another thing also you can do, you can have multiple tests in the same file. So I can have this test here, and then I can also have a directive of test for another test. So you can have multiple of that in the same file, and you testing, maybe if you want to test different functions, you can do that. So this is something that you have to know. So let me remove that. And what else and yeah, so this was just an explanation. I'm going to quickly, before we run out of time, to Let me deploy to a test net. Yeah, let me do that. So to deploy to a test net, you have to make sure you have created your identity. Because if you don't have an identity, you're not going to be able to do that. And you use this command. So Stellar contract deploy, which just makes sense. You know, you are deploying a contract, and the target is it's gonna be the hello world wasm, which if you go here, you're not gonna see it. So you're not gonna see it now. So it's not here. You're not gonna see it, but when you deploy it, you're going to see it. And the source account is going to be Alice. The network, very important, because they're deploying in a test net. You have to, if it's for the main net, it's going to be a different thing. But here you deploying to a test net, and then the alias is going to be hello world. So alias is just another name of the project. So it's like instead of, you can later use the alias instead of the contract ID. You know, just like Alice is the alias of your contract address. No, sorry, not your contract address. Your wallet address. Now, hello world will become the alias of the contract ID. So the contract ID is something like only start with C. So it's something like that. So this is what we're gonna be doing. We're just gonna deploy it, and once it's deployed, you're going to see it on the test net. No, I made a mistake. I used Alice. I should have used Ben. So let me put my name. Where is Ben? Ben. So I'm changing Alice to Ben. Release no site. Oh, one thing you have to do before that, you have to build. You have to build. It was not built. It was just compiled. So to build it, so you run the test to build it is Stellar contract build, and so this is, so we build and then we deploy. So I forgot that step. It's gonna take a while. There's something. I'm gonna have to make a video for tomorrow because we are running out of time. Because I wanted us to work on something. To work on storing data, and when we make some changes, and we also do the test together. We see how we can change the test. So, but it looks like the time is really running. So I'm just gonna, I guess I'm gonna record a video. I'm gonna go on. So after this class is over, I'm just going to continue. So this part we are building, and so far with what we've done, does anybody have a question? So far we've already done. Anyone has a question? And so while we are compiling, because I guess we all understand this, so to save time, I'm gonna jump into storing data, because here what I just did here is just to build it, and then we're gonna deploy it to the test net. And once deployed to the test net, I can actually even see this contract on the Stellar Explorer. I can go to the Stellar Explorer and I'll see that my contract was actually created at this time. At quarter past whatever, at 7:45, I've created my contract. You can see see it on the testnet. And here, because we're dealing with the CLI, we don't have a front end yet, so we cannot really use React to get all this information from the blockchain. So we're using the CLI. So this is one of the command. This is a command that we use to take a function and then put an argument inside a specific function. So here we first invoke the contract that has this address. So we're getting the contract that we created. And then we're getting the source account. Like in our case, the source account was Ben. And then we also specifying that we're working on a testnet. And then we write our function. So our function is hello. And then what happens in that function? So 2, there's that parameter that is 2, and then we write RPC. So this is just going to take the RPC into that function, and then it's going to print out this vector. I hope it makes sense. Does it make sense? Does it make sense? If you're confused, let me know. So I know this can be quite confusing because we have so many lines of instructions. So we are just trying to work with the smart contract. We're trying to interact with the smart contract. We're using the Stellar CLI, the command line interface, which is kind of like the ugly way of doing things. The ugly way of it's not beautiful, because the beautiful way of doing things will be us having a front end where a user can just put the RPC somewhere and then click submit, and then something like that is going to be outputted. But we're not doing that so far. We're not doing that. We just using the command line interface. And when we trying to interact with a smart contract, we have to specify which contract we are dealing with. So here we put the contract ID, and then we also have to put our source account, which will be which account is going to be interacting with the smart contract. In this case, Ben is going to be interacting. It can be any other contract, but that contract, if that contract is allowed to do that, is going to be allowed to do that. You can also put restriction in your smart contract, which won't allow other addresses to be able to interact with it. So it depends on the smart contract that you created. But our Hello World smart contract is open. So any address can be able to interact with that. I don't know if it makes sense. Any wallet or any address will be able to interact with that. So that's what's happening. Like so far, we've done that. So now we're going to deploy. So we're deploying the WASM. We're not deploying the code. We're deploying the WASM, which can be found here in under release. So WASM release. So this part here, this is what is being deployed to the blockchain, and you can see I had an alias before called Hello World. So now it overwrote that alias, and then it gave me another. This is a contract code that I can even find in the testnet. Let me go to the testnet on the Explorer. Come on. So I'm going to go to the Explorer. So Stellar Explorer. Stellar Explorer. So when you go to Stellar Explorer, we have to specify that we are on the testnet, because that's where we deployed our. This is where we deploy our smart contract, and then let's see if we can find our smart contract. So you can see, what time is it? It's 7:46. So it was created at it's like almost 5:45 UTC. So we're not using our time here. You can see we've created it, and we can see which address actually created it. Which address? Let's look at my address. What's my address? Let's go up. I think I wrote it was somewhere here. My address starts with GD and ends with PZ. So let's look at it. GD PZ. So we can even see which account created that contract. So let's go back, and we can also interact with it like that. So I think I have an Alice there, so Alice will be able to interact, but we have to change the address. We have to put the appropriate address. So we have to take this one, copy, and we have to change that address there. Oh my goodness. So we change this address to the contract address that we actually created ourselves. So we're gonna do it here. And so you can see simulation identifies read only, and it printed out what we expected. So here I didn't use Ben, so this is another account that was able to interact with it. So because our smart contract did not put any restriction to any other addresses. Yeah, now I guess it makes sense so far. Everything makes sense. And now we're running out of time. I'm gonna have to make a video. You know what? I'm gonna record a video to what I wanted to just to explain everything here. I'm going to explain it in detail in a way that makes sense. And then I'm going to also show you how to write a test, like step by step, how to create a test. And then I'm going to give you a problem for you to do over the weekend, because now we're running out of time. But since we left with 10 minutes, I'm just gonna go through this code and let's see how far we go. So we have a working hello world. Now we're creating another one. So remember, when we're creating our hello world, we use this command stellar contract init, and then the name of the project that you want to create. But here we want to create another project. So we use this flag name, like we use this specific flag here, the dot space and this flag here, to create another folder inside this folder. So we're gonna create it here in this folder. So if I do that, it's just going to create another project inside that folder. So you can see where is it? If you see in contract, okay, we have a new folder called increment. But if I didn't put this flag here, then it was going to overwrite it, and the initial project is going to disappear. The hello world won't be there anymore. So that's what it does. And now we're going to create a counter, and we're gonna go step by step. We're gonna create something that does this, but it's going to be a little bit different. We're gonna have a public function increment. We're gonna have a decrement. We can also have a view current number, current counter. Where is the counter at? And we're also now gonna also create a test to make sure that all of that work. So we're gonna do that. Let's go to our project. Okay, let's close these ones, and then we're gonna go to increment. In mind, whenever you create a project, it's going to have this default hello world. We're gonna have the default hello world, and so the first thing is we have no STD. We have used Soroban SDK, and everything's gonna be using. In this case, we're not gonna be using a vector. We're gonna have the environment, and we need symbol short to be able to store. What do you call it? Let me write it here. We're gonna have symbol short to be able to store small characters, like characters in a light way. So you have symbol short. We're also gonna have symbol. And we have contract implementation. We're gonna remove vector eventually. You're gonna see some warning as we go on. The first thing that we do is we wanna create a key that's going to point to the counter. And that's the reason we use symbol short, because that key that we're going to be using will be of the type symbol, and it's going to point to the counter. It's kind of like when we're using vectors, you have a vector that has a key, and then it has something that it points to. It's just like you have a empty paper, maybe paper number 1, and then there's some writings there, or it's pointing to page number 1 has this specific writing, page number 2 has another writing, page number 3 has, so it's just pointing it to a specific place you want to point at. So we're gonna declare a constant, I'm gonna call it counter, and then it of type. Remember, we have to also specify which type it is, and we're going to use the symbol short to store what we're gonna be using to point at. So in this case, we're storing a string, it's symbol short, type symbol short called counter. It can be, so now this is what we're gonna be using to point. And here, contract, we're gonna call it increment. Yeah, let's call it increment. Increment contract. Increment contract here as well. We're gonna call it increment contract, where we are implementing. So far so good. Now we gotta, what we're trying to do here is we want to create a smart contract where you can increment a number. So let's say it starts with 0, and then when you call this function, you call it, for example, increment function, it goes up, become 1. You call that function again, it becomes 2. You call that function again, it becomes 3. And then we're also going to have another function that will decrement. Then we just work the opposite way. When you call that function, it goes down. You call that function, it goes down by 1. And then we're going to also have a function that's going to view the current number, the current where the number is, the counter. So that as well. So here we're going to remove this. We're not dealing with vectors anymore. And we're going to change this function name to increment. And we're going to have the environment. But since we're not taking anything from in the parameter, we leave it like that. We're just stealing the environment. There's not going to be anything that we are taking from, anything that we are inputting. It's just going to increment. When you call a function, you just increment a number from 0, going to be to 1, 2, 3, and so forth. And what do we want to return? It's either maybe you want to return a U32, maybe a I32. It's up to us. Let's select I32. So when we call this function, it's going to return a number. So that's what it's basically saying. Now that we have all that sorted, now we gotta now get something from where this thing is pointing at. I don't know, counter is pointing to somewhere. We wanna get what is it pointing at. But if there's nothing that is pointing to, we're going to add a 0. Does it make sense? So we've used a pointer. The pointer is supposed to point to a number. So we're gonna create a number. So we're gonna create a variable that will try to get what this thing is pointing to. If there's nothing, we're going to put a 0. We're gonna make that number point to 0. So that's what we're going to do here. So we create a variable and we make it mutable because it's mutable. It's going to be changing. Count is going to be changing. And it's a I32 because this is what we're going to be returning. We're returning I32. And it's going to be equal to. And now, like I said, we're dealing in the environment. We're dealing in environment. So this counter is in the environment. So we're trying to get what is in the environment. And remember, one of the implementation of environment, and I showed you, was storage. And there's different type of storage, if you can remember. There's instance, there is persistence, there's temporary. In this case, we're going to be using an instance. So from the environment, we get the storage. From the environment, we can also get the ledger information. We can get everything that you want. But in this case, we just want to get the storage. We want to deal with storage. And in the storage, we using the instance. And here you have to be careful. You have to be consistent. If you're using the instance, the next line you cannot be using another type of storage. Maybe you want to set, for example, you want to set something in the storage. You can't initially use the instance and then you use another type of storage. So we're gonna need to be consistent, and we then go get, we're gonna get what is it pointing to. What is counter pointing to? You're getting the get. You're gonna be using get and set a lot. So this is something that you have to be familiar with. You're gonna be getting, setting. Even the next project I'm gonna give you, you're gonna have to set and get a lot. Because getting, we're getting what is in the environment. Setting, we're setting something in the environment. In this case, we want to get the key that is counter. And make sure you're borrowing. And then, so we're getting the key that is counter. We got something. But what if we have nothing? What do we do? That's when we use unwrap or. Unwrap or, and then we put a 0 here. So if we're trying to get something from the counter, trying to get an integer from the counter, but if there's nothing, then we make the counter to point to a 0. I hope that makes sense. And we're going to stop here. I'm going to end the live, or maybe an extra 15 minutes. I don't know. It's up to you guys. Maybe an extra 10 minutes. Okay, let's go a little bit over time. 15 minutes. Let's go 15 minutes. Okay, thank you. So this is where we are now. So far, does it make sense? What about other thumbs up? Other thumbs up. Thank you. So now we've gotten something, and we also specify that if there's nothing, we're gonna have 0. Now we go into the next step will be, of course, since now we have a number, now we have to increase it because we're incrementing. We now have a number. If it's a 0, then it must be a 1. If it's a 2, it must be a 3. So we just simply incrementing the number. So this code. So this code is also equal to, we can also, the same code can also be written like that. Count is equal to count plus 1. For those who are not very familiar with coding. So count plus equal 1 is also equal to count equal count plus 1. So this is like working backward. Codes kind of like work backward. They don't work forward. So what happens here is it takes 1, and then it takes the current count. If the count was 0, then it's going to be 1 plus 0 is going to be this number. So 1 plus 0 is going to be 1. If now the count was 2, it's going to be 1 plus 2 is equal to 3. So this is kind of like what it's doing here for those who are not very familiar with coding. So this is what we're doing. So now we've added a 1. So now we have a 1, but this is outside the environment. Now we have to add it to the environment, and then we have to get this counter to point to the new count. This counter must point to this. That's what we want to do now. So we're gonna, again, we're dealing with the storage. We're gonna take the storage, and then we're in the instant storage because we want to be consistent. We're getting what is in the instant storage, and then we're going to set. Remember, if we first were getting, now we're setting because you want to change what is inside the blockchain. So we're going to be set. So the set function takes 2 parameters. So it's taking the key, and then we're gonna take the what we're trying to add. So the first parameter is going to be the key, which is a counter, and then what we're going to be setting it to, of course, we're sending it to count. So now we are sorted. We can end it here. And but there's one thing that we have to also specify is how long do we want it to stay in the storage? How long we want it to stay in the ledger? So here's where the next line comes in. So in the storage, remember we spoke about different storage. So as a dev, you have to specify where you want to store whatever you want to store, whether it's user data, whatever it is, and it has different costs when you deploy it to the blockchain. So here now we want to give it how long we want it to stay. And you can even see what it says here. Extend the TTL of the contract instant encode. Extend the TTL of the instant encode only if the TTL is provided. Not that the threshold checks the TL. There's a lot of stuff. So here is just telling us that how many ledgers are we gonna be? I mean, I can say minimum threshold 50 to 100, for example. So after 100 ledger, I don't care, you can disappear from the blockchain. I'll only need you for these specific times. So 50 ledger to 100 ledger. So as you know, each ledger is like 8 seconds, something like that, about five seconds for a full ledger. So 5 times 50, you get your time. So this is what's happening, and yeah, this is where we are. So we have our first function, and if you go to test now, before we go to test, let's see what we have here. What we're not using. We're not using. Let me save it first. And we're not going to be using vector. We're not going to be using string as well. And symbol short, I don't know what's going on. Symbol short and use import. Did I spell it wrong? So let's remove this. Let's remove vec. And let's remove this as well. Symbol short. Okay. And here you can see I have kind of like an error here. Can someone tell me why there's an error here? Can somebody tell me why am I getting an error? Yeah, because I did not return anything. So just like we're working with exactly how we were working with what do you call it, Rust. And then here I didn't put a bracket here. So yeah. So now we sorted. What time is it? Okay, for the next 5 minutes, I'm going to change the test. So we getting the Soroban vec, we getting the super, we're not gonna change the string. And here we need to register. We need to make some changes here because we're doing the same thing that we did before, but we're gonna make a few changes. The first change that we're gonna do is this must take in the contract name if you look here, our contract name is increment contract. So that's what we're going to put here, because now we want to test it. Okay, we have that. And then the second step is we want to get the contract ID. So we're going to name it increment contract, increment contract client. Gonna be new, and then contract ID. And then the next step is we're now going to be taking, we now want to test it. So we're gonna be using assert equal. And then this part here, we don't need this anymore. We don't need something like that. So we're just going to be calling the function and then compare it with the output. So assert, let me just make it simple for you. So here we're comparing word and vector, but here we're going to be comparing the output with a specific number. So how do we get an output? We call the client and then increment. So client increment at the first iteration must be equal to 1. Does it make sense? Because we are calling, because if you call it as nothing, then it's going to be a 0, and then there's going to be a +1. And so we're expecting a 1. And the reason I'm working like that is for you to see that we're not really making so much changes from the original hello world. Like the test kind of like work the same. You just need to make some few changes, and you also have to think about what are you actually outputting and what are you expecting when you're using the assert equal function. So we wanted to just do this client increment. We should be a 1, so we're expecting a 1. And then we can use it again. If we increment again the second time, we're going to have a 2. If we increment again, we're going to have a 3. Does it make sense so far? And yeah, so this is what might happen. And I don't know why the vec env, you know what, we're not using a string, so that's why we have that. We're not using a vector. So you'll see, so we might, and we don't even have to do that since we have one thing here. We only have env. We can just keep it like that. We can just keep it like that, and then we save. So we have that. We have that. Okay, since I went beyond my time, let's test it first. Cargo test. You're gonna end it here. Okay, I guess what I wanted us to do is going to be a homework. What I wanted us to do now, because the next thing I want you guys to do is, and the original homework I want to give you is going to be the homework next week. So basically next week we're going to have the class that I wanted to have tomorrow, which is we're going to code something inside the class, and then the next class we're just going to wrap up everything, and I'm going to give you a project where I'm going to like kind of like follow you guys until you complete it. So for now, I'm going to share this code on the GitHub, and I want you to add two functions. The first function is going to be decrement. So you have to decrement, and then the next function is going to be view the current counter. So wherever the counter is, you must view it. And after doing that, I will also want you to create a test, because so far the test is only testing increment. You can go on and continue and test other cases like decrement and view current. And then you also have to think about what you're expecting. What's the output that you expect? Because if you put the wrong expected output, then you know you're not even going to know if your application is working accordingly. So you also have to be mindful of what is the correct output that you're expecting. But before we go, just one last questions, and then we go. One last any last question?
I just wanted to know if we could get the code that you did on the last Wednesday or Tuesday, that bank app that you set up, just the question and the code. I don't know if you want to upload it in the Drive, the Google Drive, because that would be cool as well. Because I just wanted to see it and then just like see exactly what you were doing, because I followed along, but I just want to mess around with it a bit more. And actually having the questions written down is, you can play around with it. You can try and simulate it in different ways. So cool. If you can, thank you.
So I hope I didn't modify. I look for it. I hope I did not make some changes. Yeah, but I'm not do that. And also this one as well. So here you just have to, like I said, I think I'll write it some way, like to tell you exactly what you should do. I just want you to create two functions, and you can do it tomorrow. Tomorrow I won't be available, unfortunately. So you can use that time to just add those two functions. And I think it's even better that we didn't rush, because the type of exercises I wanted you to do was kind of like more difficult. So it's going to be good to do this thing alone and me not guiding you for the remaining of the functions. And yeah,
would you mind,
guys. Yeah.
If you get a chance, could you share the next week's homework assignment take home thing? Can you share that as well with us? Because then we can come with questions to you in the class as well.
Yeah, I will.
Thanks. Appreciate that.
I will this week.
Cool. Okay, thanks, Ben. Appreciate you. Enjoy the rest of your night.
Appreciate you too, man. Thank you. Thank you for joining.
Cool. Cheers, guys.
Cheers.
Thank you, Ben.
Thank you. Thank you for joining. I'll see you next week.